afternoon, guys. Today I just want to recap something that was cut out of the 6-1A video, and then I want to talk about 6-1B, which is pretty much a review. So the first thing I wanted to mention is that when you do the mean and standard deviation on the graphing calculator for a probability distribution, so meaning if you have a table like this and you have each value with its probability, you're going to enter the random variables into L1, the probabilities into L2, and then what you're going to do is you're going to use one var stats. There was a typo on the handout. You're going to use one var stats, and you're going to use the frequency. So the list is L1, and if you were doing just a regular set of univariate data like class average, standard deviation, you would leave the frequency on 1, meaning each number has just one observation. But now the frequency is going to be the L2, the probabilities. So if you do that, your calculator will give you an X bar, and the X bar, you're not going to write X bar, you're going to write, the X bar is the mean of X, and then the sigma is the sigma of X. So you need to know the correct notation to use, even though your calculator is not giving you that notation. Okay, so again, it's one var stats, not two var stats. Tell your peers, in case they're not watching this video, that there was a typo on the 6-1B handout. Okay. All right, so now I want to take a look at the 6-1, on the 6-1A handout there was a typo. I'm going to look at 6-1B. So 6-1B is essentially what we've already done in the way of calculations as far as the normal curve, all right? But there's a couple big ideas I want to make sure we talk about, okay? So if you look at 6-1B, it first starts by asking you, it defines a continuous random variable, which means that it has an infinite number of outcomes, right? A variable's value x takes all values in an interval of numbers. And we're now going to think of the proportion of observations in that interval as a probability. So what is the probability that we get an x value between certain values, or greater than a value, or less than a value? And so if I ask you to pick a number between 0 and 1, and we think about that sample space, there would be an infinite number of possibilities, right? Think of a random number generator if you were going to get a random number between 0 and 1, right? If you know anything about the betweenness property, right? There's always a real number between any two real numbers, A and B. So there would be an infinite number of possibilities. So in this case, the sample space would be the set of all x such that x is a real number, right? And x is somewhere between 0 and 1. So what would that look like as a distribution? That's going to be essentially every number has an equal probability. So between 0 and 1, right? Which means that if this area here is 1, that must mean that this height is 1. Which is a little bit weird because, you know, this is supposed to be the probability. And this is x, right? And so the probability is not 1 of any particular number. In fact, the likelihood of picking any one particular number, like 0.32578, right, in an infinite number of numbers, is just 1 out of essentially infinity, which, as you know, is approximately 0. So we can look at values in intervals, and the big idea here is that we are essentially looking for an area. So you're going to, basically 0.3 to 0.8, 0.3 to 0.8. There's a width of 0.5, the height of 1, and so that would clearly be 0.5. Right? So each interval has a particular area, but the big idea here is in C, whoops, another typo, I'm doing great here. Forgot the parentheses. Probability that x is equal to any one particular number, right? This is essentially 0. Okay? Because only intervals of values have probabilities, have positive probabilities, okay? And you had my notes on Schoology yesterday, but I just wanted to clarify that, okay? Now, the next page, which if you did go through those notes, the notation probably looked a little different, but the calculations are essentially the same. Okay, so we have a situation where we're looking at an SRS of 400 American adults, and we're asking them, what do you think is the most serious problem facing our schools? So the suppose part is really the parameter, right? It says suppose that in fact we know that 40% of all adults would answer violence. So that's probably, we don't know that, we're kind of assuming that to be true, right? So that 40%, that's the parameter. That's like a mu in a normal curve, right? And so we are trying to look at what would happen if we take samples. If we take samples, we're going to get a p hat. So a p hat is like an x bar. It's a sample proportion. And we're going to do this over and over again, okay? And they're telling us that the density curve for this scenario is normal, right? So the density curve, this is from a sample, let's just label that so you know, is normal. And this is the distribution of p hats with a mean of 0.40, and they tell me a standard deviation of 0.024, right? So we're going to have now not a mean or a mu, we're going to have a p, and we're still going to have a sigma, okay? And so when we are doing our normal calculations, as you saw in the notes on Schoology from yesterday, really we're just tweaking them a little bit. So now instead of saying p of x is greater than, it's p of proportion of x, it says believes that at least 45% of the sample believes that violence is the most serious problem. So p hat is greater than or equal to 0.45. Okay. So think of this scenario here on the normal curve. The center is 0.40. We're looking at 0.45. So this is the p hat, and now we need to find a z-score, right? We're going to do the z-score exactly the same way, right? It's going to be the observation minus the center divided by the standard deviation to figure out how many standard scores are we away. Okay, oops, that was supposed to be step 3. Doesn't really matter. The order of the steps is not important. So now, look at my z-score. It used to be x minus mu, but now it's p hat minus the center is the p over the standard deviation. And we're going to do our calculation. Not that you need me for this. We got 2.08. And we're looking for this area here with the z of 2.08. So we would look that up. The area to the left on the table is 0.9812. So if we subtract that from 1, we can figure out that the proportion or the probability that a p hat, a sample, provides 45% or more thinking violence is the biggest issue, is a mere 0.0188. I don't know if you can see that. Did I get that in there? Okay. So when we are doing these calculations, the interpretation really is the biggest change. We're now interpreting this as a probability. So we're kind of crossing the bridge, so to speak, from thinking of the answers to the normal calculations, which are continuous random variables. The answer is now probability. So there's a 1.88% probability that a sample would say, that 45% of a sample would say yes, violence is the biggest issue, assuming that the true percentage for the population is 40%. So that's very unlikely, all right? So we're going to do something with that probability in the second half of the school year. We're going to make a decision about the assumption, okay? So please try the problems in 6.1b for homework tonight. Try to get some of that done. Today in class, you're going to be looking at the expected value sheet, okay? And I'll post those answers for you on Schoology. Have a great day, folks.